uh, we will start with the seminar. So, good afternoon, everyone. I welcome you all for today's webinar on electric vehicle modeling and simulation. It's a great pleasure for me to introduce our today's speaker, Mr. Suraj. Mr. Suraj is a founder and CEO of Decibels Lab, Bengaluru. He has done a lot of research and development in electric powertrain area, such as batteries, controls, HVAC systems. He also worked on projects for Mercedes-Benz, Fiat, and Fisher Dynamics in the USA. So, without wasting much time, I would request Mr. Suraj to start with the session.
Uh, Hi, good afternoon, everyone. Uh, Thanks, by the way, for the introduction, and also thanks everybody for joining in. Also, the thanks for all the hosts who have been making, specifically Saurabh, whom I have been in contact with, coordinating all the activities to host this webinar. So I would be very happy to just share across the things. And before we get started, I would like to confirm if my screen is visible to all of you because I don't want to have a blindfold conversation. Yeah. So can anybody confirm if the screen is visible for you and if my
Yes,
audio is
sir. The
clear?
screen is visible. Yeah.
Okay. All right. Great. Let's get it started. So I can't see how many people are there, but as I'm sharing my screen, but that's fair enough. And I know it's really appreciable thing that you guys have joined for today's webinar. It's very needed, as I would say, not only as a technology in terms of learning, but if you think as an engineer, so we are always there to solve problems at a very bigger picture, right? And that's why we graduate and we work for organization, even though we work for earning money, but nobody pays us the money until and unless we do something which is valuable for the company, right? So end of the day, that value is basically a tech, our product we're trying to develop. At the end of the day, those products are trying to serve the purpose of our customers. So on the part of it, I think in the mobility, we have been good on the ride of what we have been developed, but somewhere down the line, we've been adding a lot of emissions to the whole atmosphere. So that has been causing too much of problems in terms of health. There are a lot of health issues with people, and maybe it's asthma or lung cancer. A lot of these things, and I think e-mobility is something which we can, bring into a play that can address. So as we see a bigger picture, so the thing what you're trying to learn here is basically somewhere you're trying to implement as an engineer when you graduate, work for an organization, possibly make an environmental better, people lives better, and the country's economy better, right? So that's a very bigger picture of what we're trying to learn here. So give a gravity of a content which we will be learning now. So I would not have this presentation as a webinar in a very boring way. I would try to give you some very interesting data, very tested information that nobody could possibly share you as in general as an information to the webinars. So that's my efforts of putting it today, and that's I expect that of your efforts to have that very interestingly perceived. So if you have any questions, you can always drop them in the chat box. I believe the chat box is available in Google Meet. So if so, please do drop your queries in the chat box. I'll try to take them quite often in the mid of every 15 minutes and answer those queries for you. Great. So let's get it started. By the way, the objective of today's webinar is this: to understand the influence of parameters and consider to build an accurate simulation model. Right. So let's. This is the flow of the webinar. What I will be having. We expected to have about 1 hour. May extend by 15 minutes. If you have pretty decent questions. Yeah. So be prepared with your questions. That's always a way to learn. And also make you engaged into the whole learning throughout this webinar. So that's what I'll be covering up, and that's me on the left side, right side. So let's start ahead in understanding technically that what is the goal of the simulation, right? And what is the simulation, first of all, because it's a very new topic, because we have heard simulations like CAE, CFD, all these things, right? We might have never heard about something like model-based design. It's a very rare thing because a lot of universities may not have that subject right now, but it is a very prominent thing which is used in the industry. Okay, So that is specifically called as a model-based design. So we use softwares like MATLAB, Scilab, Ricardo, AVL, GT Suite, or like maybe some of the softwares like 1D simulation and softwares like that. What we can do is basically we can write the equations of physics and use our system knowledge and create the model excuse me, of a car or a bike or a truck or a train or plane or anything. We can be able to evaluate how the vehicle is going to behave. Okay, maybe what is that vehicle is going to behave. Let's say take few examples. Okay, imagine if the car is there and I want to know what is the range that car can give me if I charge it for 1 kilometer. Sorry, if I charge the battery, what is the range it can give? The range means if for the single charge, how long it can travel, right? So how long it can travel depend upon how much energy does the component consume, right? And then the amount of energy the component can consume also depends upon various parameters. Maybe the way you drive, right? Maybe the road conditions, traffic conditions, temperature conditions of an atmosphere, number of people sitting on the vehicle, right? There are many parameters which can actually come into a picture, which contributes at the end, as we call it as number of kilometers for a 1 liter of petrol, or let's say for a 1 kilowatt battery, you can run the vehicle for this many kilometers, right? So I'm just giving you simplistic examples, like what we are trying to learn in the whole webinar down the lines, because you would not have driven a bike or a car. It always look at my bikes give me like 30 kilometers per liter of a petrol or something like that. But the same bike will not give you exact same kilometer if you drive them in the maybe guard section, right? If you drive in the bumper to bumper traffic condition, it may not give you the exact same 30 kilometers, right? So it may give the 30 kilometers when there is a highway condition and when the roads are open, you're driving at like 60, 70 kilometers per hour. It is going to give you that much. Okay. Like if the temperature of that day is different, so it may not give you the exact numbers. If the like air density is not that better that day, maybe the above the sea level you go, so the air density reduces, right? So like a component, a vehicle is being subjected to various of these conditions, and with these conditions, you get a mileage. Correct. Even though it also depends upon the way you drive the vehicle. If you drive too aggressively, if you drive in the wrong gear ratios, a lot of things can happen to the engine, and it will give you lesser mileages. Now we talk about electric vehicle, right? That's the intention of this webinar as an EV pattern simulation modeling. The same way as an electric vehicle, it contains all these components, right? I mean, you guys would have been pretty much aware about IC engines, right? Like, air intake system, exhaust system, and all the combustion systems, and then any of the other fuel injection system. All these systems comes together, and then they make a functionality as an engine, and then that gives an output to a transmission, and then to a final drives, right? But if you electric vehicle, so electric vehicle have lesser number of components, but it is very complex in its shape. It's very complex in its functionality. It's very complex in its sensitivity. So it's like this, if somebody gets sick, like if the weather is like 10 degree less someday, maybe some people will get sick, right? It means they're very sensitive to atmospheric conditions. Like, if it is raining for continuously 5 days, maybe they may get sick. If it is very cold above below like 20 degrees Celsius, they may get sick. Exactly the same way. That's what a challenge with EV. The number of components might be less, but the complexity of those components are really, really tough to develop or define. And that's what brings us an interest to understand this and work on the simulations. And every goddamn industry requires simulation engineer. If you take even Rolls Royce to Audis to BM to Mercedes to even Tata, or it may be anybody, even a startup, it could be a billion-dollar company, tier one supplier. They require model-based design engineers. That's what we're gonna be discussing down the line. So the idea is here of this goal. Why do we perform simulations? So we perform simulation to know component sizing. Okay, imagine you are developing a Formula Student car, right? Okay, what is the motor size I have to use? What is the battery size I have to use? What is the conductor size, contactor size, fuse, pre-charge relays? A lot of these components comes into a picture, right? When you have to develop a vehicle, I would say at least a powertrain part of it. The same way in a car, you have all these components. There's a transmission, obviously there's a wheel and transmission, and then the motor. Inverter is basically a motor controller, right? Which is here. I'm sorry. Yeah. So if you take this, so there is a motor here, and then there's an inverter here, then there's a charger and onboard DC-DC converter, charger, the battery management system. This is a battery pack itself. Then there's a battery cooling system. Then there is a battery heating system. Then there is a air conditioning system, right? There are multiple components all in together, which which brings up an EV as a system. Now, I want to know, okay, what is a transmission? You're a mechanical engineer, most of you, right? Or maybe another department, if you know about transmission. So it's a gear ratio, sets of gear ratio, right? So, okay, what is the transmission gear ratio I should use, right? That's a very big question. Then in the transmission itself, there is a manual transmission. Then there is an automatic transmission, right? If you consider manual transmission, that's a end product, right? Automatic transmission is an end product. But again, in automatic transmission, you have something like CVT, right? You have hydraulic based actuation systems. Like these are planetary gear systems comes into a picture. Okay, what type of transmission you should select? For this powertrain, what type of configuration will fit it in? Then on top of it, like what would be the gear ratio? Okay. So for which is required for this vehicle into a place, maybe if it's a two-wheeler or a four-wheeler, truck or a bus segments or something like that, right? So all these things which we study as a part of this activity, where we will be able to understand, okay, what is the transmission. Then taken in terms of the motor, right? If you take it areas of the motor, so where you'd be studying something like what is the motor torque, right? The motor torque is basically there are again two torques. One is nominal torque and one is a peak torque of the motor. Then again there is an RPM of the motor. Okay, what should be the RPM of the motor? What should be the torque of the motor at a given conditions? Then also on the other side, okay, what would be the temperature of the motor? If I run the motor for 1 hour, right? What would be the motor efficiency when I'm running the motor, right? And what if the temperature of the atmosphere is there that is influencing on the motor? What would be the losses in the motor because of the temperature, right? And if you see an efficiency table, I'll show it across to you. Efficiency of the motor will vary with respect to various different conditions. Okay, one is your RPM of the motor, torque of the motor, and temperature of the motor. Now, all these parameters are dynamic parameters, right? These parameters are varying continuously, and then they're going to influence on the motor's efficiency, and that basically your energy consumption into a place, right? So like this, it is also getting changed. So it's a dynamic system into a place. Then you have a motor controller, you have a DC-DC converter, which is here. Like all these things are going on. And if you take a battery pack, okay, what should be the kilowatt of the battery pack? Okay, it means what should be the size of the battery pack I should use. If I'm using a heater, in a hotter condition, like very cold conditions, maybe if you go to US or Canada or Europe, the temperature going up to -10, -15 degree, -30 degrees Celsius, right? So at that time, the batteries requires heating. I mean, you need to heat the battery pack. That time you need a heater. If I have to decide a heater, okay, what's the size of the heater? Again, what's the kilowatt as a size of the heater which I should use? Again, if the temperature is hot, I should use a cooling system to cool this battery pack, right? Maybe conditions like where we have in India, like Chennai or even in Mumbai in cases, if the temperature goes to 40 degrees Celsius, I'm not sure if it goes to 40 there. So then again, you need a cooling system to cool the battery pack, right? You also need a cooling system to cool the motor. Okay, what should be the size of this cooling system? We all study, right, thermodynamics and stuff like that. So we're going to use that equations in place, and then we're going to build this model. And the idea is to understand, okay, what is the component sizing? That's a very first and functional parameter we perform simulations for. The second parameter is we study the influence of parameter on the energy consumption. What does this influence mean? Okay, so I told you, if you drive a vehicle, maybe you get an X mileage. If your father drives a vehicle, you may get a different one. Maybe if your friend who drives it very aggressively, if he drives it, he may get less different mileage, right? So it means the behavior of the driver also influences the energy consumption. It means the mileage of the vehicle into a place, right? Maybe for the temperature conditions, if the atmospheric temperature is really, really hot that day, right? Maybe that will give you a different type of energy consumption. It's the amount of energy consumption. If at that day traffic is really bad, okay, you have to stop at every now and then, and you're burning the fuel in the traffic signal, so it may consume different amount of energy. It means that there are a lot of parameters which come together to cause something called energy consumption, right? I'm just talking about energy always because that's what it matters. If you design an electric vehicle which consumes lowest amount of energy, then you have best vehicle as possible in the whole market, right? And the battery pack is the most expensive element. You can't just keep bigger battery pack because your vehicle will cost you more and nobody will buy the battery pack. If you keep it smaller, it gives you a lesser range, and nobody would also be willing to buy the vehicle. The same way, you should pack this battery in a very perfect sizing. That's one side. And what if you can consume lesser energy to drive your vehicle, right? So by optimizing the components, that's what we study as the influence. There are a lot of influences which influences the vehicle to get the output of an energy consumption. Then component sizing optimization. Maybe let's say I took a transmission, right? Let's say there's a 6 gear ratio and 6:1 gear ratio. Okay. Now I think I don't know whether the 6:1 is correct. Maybe it's a 6.2:1. How do I size that correctly? Okay. So I can't actually go and build a vehicle, right? I mean, test all these things, and it becomes a very expensive thing to do that, right? So I'm doing an optimization studies to know, okay, I should choose between 6.6:1 gear ratio or 6.2:1 gear ratio, or it may be 6.1:1 gear ratio, right? And then maybe if you want to check about a motor, okay, should I use a motor of a 6 kilowatt or should I use a motor of a 6.1 kilowatt? This number looks very small, but it makes a lot of sense when you're trying to do a simulations into a place. Like the same way, as I said, here at the last, it comes to a very important factor. You want to achieve a vehicle which is having the lowest energy consumption, okay? And then the last point is obviously scalable or modular. So this is what interests to a simulation engineer and why we build simulations. And now all of these things are actually done, right, without even having the vehicle as a whole object. We are doing all these things just in the computer, right? So that you could run enormous number of simulations and then you can get a data. So you can size these components. Okay, my motor size is 5 kilowatt, 150 Newton meter torque, and this is the efficiency of the motor. You can do it for the cooler, you can do it for the heater, battery pack size. You can do a lot of these things in a way that you can define a powertrain even without building the powertrain. Okay, so that is the interest. And now if you see, as I was just giving to the block diagram, this one talks more about from the realistic point of it. You have a motor here, right? Then you have a transmission or a differential. Then you have an inverter, which is basically a motor controller. Then you have your power distribution module, which is basically also a DC-DC junction box. So basically, this is charger to the vehicle, which you see here, which is sitting here into a place, right? This is a charging input, and then this is a big battery pack, which is sitting here. So this is a way how Nissan has put across into a place. Yeah. So now the idea is basically to come to a conclusion that what all the component sizing we have to do and optimization studies we have to do, and that's why we use a simulation in our studies. So let's start with the one of the factor. I would like to know if this is you are able to understand why we are trying to do a simulation. So I would just go back to my chat box. If you have any questions, you could just drop your questions here. I could see those questions and try to answer to you. Okay, so is my voice is not good still? Is it echoing too much? Can anybody confirm?
No, proper.
Okay, sure, that's good. So if you have any questions, guys, you can just drop the questions here, so I could see those questions and answer back to you. So going back to the slides here, I don't want this to be a monotonous session. I know it's a complex thing to understand in some cases, but if you ask questions, try to put your, a creative hat and think, okay, what would be the reason behind it? So maybe that makes it very interesting for you to learn. So what we mean as a drive cycle, I would not go too deeper into it. It's a data which is plotted in an Excel sheet or anyway in any other sheet. So which tells you your driving pattern. Okay, if you take like your this is a slot of t, which is means time. This is let's say plot of velocity. Imagine the way you drive your vehicle. If you put a device that can measure the velocity of your vehicle with respect to time, and then you collect the data and you put those plots, and if you're able to make them into some visible format like this, that's what is basically your drive cycle. Okay, maybe you may drive like this. I mean, as a driver. So, but if you give it to your friend, maybe he's too aggressive. You will just do too much of this stuff, and he will drive too fast on your vehicle. The vehicle is same. The distance where you have to reach is also same, but the way he drives is different. Maybe if you give it to somebody who's elderly, right? Maybe at a little older age, maybe they will drive it a little calm. They don't have too much of your driving variations. They drive it very calm, right? So it means there are 3 different drive cycles. I mean, the same vehicle, same distance that we have to cover, but the people have driven in 3 different ways, right? So it means this picturization is called as a drive cycle. Okay, so if you drive like in the green color, it means you're driving very calm. I mean, very contented and very peaceful. And if you're somewhere here, you're a moderate driver, right, in the red color. If you're in the blue, maybe let's say you're a very aggressive driver. So you can have a same vehicle, but to travel this distance, okay, maybe this is time and time considered to be in a distance in the format, right? Let's say this is 10 kilometers. Okay, this distance is 10 kilometers. So to travel 10 kilometers, maybe the guy who is in green, okay, who drove in green, would have been consumed, let's say, 200 watt per kilometer. Okay, so maybe the guy who drove it in red would have been consumed like 250 watt per kilometer. Okay, maybe somebody who is driving it in blue would have been consumed, let's say, about 300 watt per kilometer. So this is like about 100 watt of a difference, right? It's about like a 50% more energy consumption with the blue guy compared to the green guy was driven the vehicle. So what it is the meaning as an overall is the way you drive a vehicle impacts the energy consumption of the vehicle, right? So it is a very end product what we're trying to discuss. But as an engineer, what we're trying to understand is, okay, why does this happen at a powertrain, right? So if this guy consuming 200 watt, this guy is consuming 250 watt, and this is about a 300 watt. But why? Right? That's what we're trying to think as a engineer. And maybe if you give it on very other guy who is a layman, he would tell, okay, this is a mileage of the vehicle, right? But for me and you as an engineer, the interest here is to actually understand, okay, why does it happen, right? So that's what we've been trying to look through some of the data which is here. As we say, okay, so there's an acceleration part which is here, right? And then there is a constant speed part, and then there's a deceleration part, then there's a constant deceleration part, and then there's a stop time which is here, right? So it means what exactly when you're driving, when this blue guy was trying to drive, right? He was trying to drive too aggressive, right? So it means if you take like something like this, he is expecting the vehicle to reach the speed from, let's say, this plot to this plot. This is 10 kilometers, right? Maybe this is, let's say, about 50 kilometers per hour, and the time is this, and he's trying to reach that 10 to 50 kilometers within a very short time. Okay, it means that the vehicle need to be accelerated too fast, correct? If you understand the term of acceleration, right? So now, if the acceleration is to be too fast, basically the torque has to be very high, right? If the torque has to be very high, basically it's an electric vehicle, then the torque is directly proportional to current, basically the flux, and flux is directly proportional to current, right? The current has to be supplied a lot, and the current has to be supplied a lot. Where it has to be supplied from? It has to be supplied from the battery, right? So end of the day, power is equal to V into I. So you're consuming more amount of current, you're basically consuming more amount of power. So it means you're consuming more amount of energy from the battery, so that your battery will die too fast, right? So I mean, very simplistic way of thinking through. I'm just giving. I know I don't want to go too complex into it, because we have course where we just do studies and drive cycles for, let's say, like 6 hours, something like that, and we build a powertrain simulation model where we study all the components and its behaviors with respect to different drive cycles. So now, if you consider a reality, right? Like how do a company have to design the motor size, battery size? How do I have to tell? Okay, for example, okay, they can't tell you, right? If some company is trying to sell you electric car, maybe Tata Motors or Mahindra, they can't tell you, okay, if you drive, the vehicle will give you 100 kilometers. If your father drives, vehicle will give you 120 kilometers. Now, if your friend drives, it will give you like maybe 60 kilometers. And if the temperature of the atmosphere is really, really high, maybe the vehicle will give you maybe 10 kilometers less. I mean, you will slap on the sales guy, right? I mean, you'll never listen to him for sure, because it doesn't make any sense, right? So, but as a powertrain engineer, this is all is happening in the back end, and you have to still have an idea, how do I put it across into a package that makes it function well. So that's what we're trying to study in terms of a drive cycle. So if you see here, we do simulation studies, and where we extensively understand like how the motor is operating and where exactly the motor is operating when the vehicle is running. And if you see this part of the screen, which is here, like, this is a motor graph, this is motor negative graph, this is motor positive. It means this is in a driving condition and this is in a braking condition. Okay. So you could see where all the motor is operating. Most of the times the motor is operating possibly here, it is operating here, it is operating here. So by this way, I get to know, okay, maximum motor torque I require is somewhere around this, which is about like 180 Newton meter. And the maximum motor RPM is somewhere around, this is radian per second, not RPM. So it will come around, I think, 6,000 or 7,000, somewhere around those numbers. Okay, I think 10,000. I'm sorry, this is 10,000 RPM for the Nissan Leaf. So I'm trying to study where the motor is operating. I mean, I'm not bothered one way that how the driver is driving. As an engineer, I am more bothered that where does the motor operate? What is the motor current required? What is the motor voltage required? What is the efficiency of the motor at a given point? So if you see these small dots here, right, like 94, 96, 96.5, 94, this is all your efficiency points. What I am as an engineer is more concerned. Okay, when the vehicle is running, where exactly the vehicle it is operating into a place, right? So this is what gives you an idea as a one step back. How do you visualize something as a drive cycle as an engineer to see the powertrain sizing into a place? So what it means is that the way you drive the vehicle, I don't want to go too deeper because I just have 1 hour. I think almost I killed an half of the session already. So if you see here that different vehicles have different acceleration profiles. Maybe sports car have a very quicker acceleration requirements. Maybe city car also, because you have to overcome the traffic, you have to move on, so it may require. So like a lot of these conditions will influence the energy consumption. So the objective of a powertrain simulation engineer is to study and design a powertrain which consumes as less energy possible, right? And all these drive cycles will influence. If you see here that this is a urban drive cycle, which is mentioned here. This is a rural drive cycle. This is a highway drive cycle, and this is a racetrack drive cycle. So each of them exhibits their own characteristics, and each of them have their own values of energy consumption for the same vehicle, for the same driver, different driver conditions. That's what we study in powertrain simulations, where it gives us a very intuitive understanding that, okay, this is how the powertrain energy consumption will happen. I would not go much deeper again in this here. Right. So if you see the driver's aggressiveness, right? I mean, I meant it in a way that, if you drive too aggressively, then the energy consumption is going to be different, right? Maybe just like an GIF image in the right and bottom corner. Okay, cool. That was one of the topic. And then let's take some questions here. If you have any questions, I'm over to you to hear any questions. So do you have any questions? So if you have any questions, you can drop them here on the chat box. So it will be quite interesting to know if you're able to follow this, or maybe, it just feels like a gyan and going over the head of these conversations. Okay. So do let me know if you have any questions and drop those questions here. I would possibly see those questions and, give you an answer back. Yeah. So how does the temperature influences a vehicle, So end of the day, I showed you some of the components, right? So there is a battery, there is a motor, and all these components. So the battery, if you take a mobile phone, right? Take your mobile phone and try to use it in hot temperature. Maybe compare it like you use the phone in your house, and maybe the temperature is about, ambient temperature is possibly about like 25, 30. If you take it outside at a hot sun and an open field and try to use your phone, exactly the same pattern as you have used, maybe play a video or something like that. Observe, okay, you watch a movie, you watch another movie of the same duration, and maybe there would be a difference in energy consumption. Maybe the meaning of energy consumption is the state of charge your battery is going to give you, right? Maybe if you started at 100% SOC, maybe let's take like in your house, you started at 100% SOC. By the time you completed your one movie, possibly you have reached something like this. Maybe let's say like 60% SOC. But if you take that same condition in a hotter temperature, okay, so outside, possibly that energy consumption will be somewhere around 50%. There's a 10% extra energy consumption, just because you use the phone outside your house at a hotter sun. And it means that, like, I'm just giving you a layman example because it's more easy to understand. Others have to explain the chemistry of the cell, what happens inside a cell reactions, problems at a cell, anode material, cathode material, all these things will come into a picture. But what we're trying to understand here is temperature influences the battery, and that means it influences the way it stores the energy and way the chemical reactions happens inside a cell. So it means if you drive your vehicle at a too hot a temperature, then obviously it is influencing the battery, and it means it is consuming. I mean, it is not capable of storing, exhibiting a similar characteristic as it exhibits at a very decent temperatures. So one, temperature influences battery, right? And the other one, temperature also influences the heating and ventilation, HVAC system. Okay, so if you have a very hot sunny day, for an example, right? So it means you're gonna definitely turn on your AC, air conditioning system, correct? So in an electric vehicle, the air conditioning system has to run with a battery power, correct? So if it has to draw from the battery power, basically it is consuming the energy from the battery. You know what is the size of the HVAC system in the car? So possibly it's about 3 kilowatt. Okay. So 3 kilowatt is an average size. If you can convert it to horsepower, whatever the number it comes into, I think it's 0.75, right? 1 kilowatt is equal to. So it's about like 2.2 HP horsepower. That is the size of your compressor, which is there in your cars, an average mid-size car. Okay. It increases if you buy a Nissan, sorry, if you buy a um, Innova, Krista, or like obviously the vehicle is bigger. If you buy an SUV, I'm just talking something as a segment of a Swift or all these vehicles into a place. So that is about 2.2 kilowatt. Okay, if you run the AC for 1 hour at a maximum load conditions, it consumes 2.2 kilowatt. If you run it at an average condition, let's say if you take even partial load, 50% of the load, it is consuming somewhere around 1.1 kilowatt of energy per hour. Okay, it means it's a lot of energy, right? If you take a Mahindra E2O, the battery pack size is only 8 kilowatt. Okay, in Mahindra E2O, so it is consuming about nearly 20% of the energy every hour. It means if you run the HVAC system on the partial load for 7 hours, your E2O battery will go out. It means the temperature of the atmosphere also influencing the energy consumption. Now, when you're driving the vehicle, I can't tell to a driver, right? Like I can't tell to a customer that, hey, you drive your vehicle with the HVAC on, that's why you are getting lesser mileage. I mean, you will not agree for that. But with the IC engines, it was different, right? Like, it will give you a lesser mileage. Okay, there's a nearby petrol station, a diesel station. You can go and fill the fuel. But for the electric vehicle, it is not like that. It will take a lot of time to get charged, right? And this is all the challenges which we have. Now, what we do as a simulation engineer, like this, I can move on maybe another 15 conditions. So these components like HVAC, the battery characteristics are influencing the temperature of the, influencing the energy consumption of the vehicle. So we are trying to study all of this parameter. Like in similar, the temperature also influences the motor's efficiency. This is a graph I was trying to draw. That if you take a say battery, and right, area under this curve is basically the amount of energy it can store. Right? We have done all these calculations in our college days. Now, if you take this same battery, right? If you subject the battery to a different temperature, maybe it's mentioned here. What are the temperature ranges? Red is 25. It means it is optimum temperature. A light green, like was a little of green here, is basically 10 degree, and this is at your 0 degree, and this is for a minus 10 degrees Celsius. It means that if you're trying to run vehicle at these different temperatures, it exhibits these characteristics. It means the area under this curve is very small. Again, why this is small? It is all the chemistry. That's your interest to learn. You can definitely take up a more deeper learnings into our place. So like these components are getting influenced by the temperature, and battery behaves differently. The motor efficiency goes wrong. Like if the temperature is too high, then the battery becomes hot. Then battery requires a cooling system. If the cooling system has to run, again it has to consume energy. If the motor temperature is hot, then we have to cool the motor. Then we need a energy. If the battery temperature is too low because of atmospheric temperature, then again we need a heating system that requires energy. Like this, all the components are consuming energy. Okay. Now, if you are able to exactly estimate considering influence of all these components, okay, that is what is called as the most optimized model. Imagine this is not a static system. The meaning of static system is, you want to calculate the amount of energy consumed at your house. Okay, it's very simple, right? You take number of lights, their watt. You take fan, fridge, whatever it is there, TV and computers, phones, and everything. You just can calculate, okay, at a max in my house, this would be the consumption, correct? But you would not use all the devices at the same time. You don't switch on all your 20 lights in the house, right? At a condition when if it is not some celebration. So you will not use it. So, but in the vehicle, it is not like that. Everything is dynamic. Like the motor operations are dynamic. The meaning of dynamic is the state of the system is not constant. Okay, like if you turn on the AC, like for example in your house, you turn on your fan. Okay, energy consumption increases, then it becomes flat. Then if you turn on a fridge, then it goes up, then it becomes flat. This is very static condition, maybe something like this. Okay, but in the vehicle it never be like this, right? It will be dynamic condition. So all these components are dynamic components. Even the way you drive also is dynamic. The traffic condition is dynamic, the temperature is dynamic, like many things, right? So HVAC system is dynamic. So when all these things are going on, basically you cannot study the system by doing some hand calculation, because it is impossible to do hand calculations for dynamic systems. So you can take a static condition as a worst case and do it, but still, I want to know the dynamic exact energy consumption. Then you need to integrate the value. It becomes there are multiple values. It becomes a challenging thing to do a hand calculations and figure it out. That is why we are there as a simulation engineer. So we build the models of using the equations, and then we would be able to study the parameters of the system. So if you don't know, simulation engineers are the highest paid engineers in the industry. Pretty much recently, an average package is at least starting from like maybe 8 lakhs plus, and most of the bigger OEs and startups, sorry, tier one suppliers. So that could go up to even 30-40 lakhs as a packages for a 6 to 8 year engineer. So this is like, I would not go much in deeper because it takes a lot of time into a place. So if you have understood the overall, the idea of what we're trying to learn here is, so EV has components, and we want to do a simulation and study how the vehicle behaves, and with respect to the vehicle behavior and the driver's driving conditions, I want to know what is the amount of energy that's being consumed. Okay. So this is a process. It takes at least of 6 months to 1 year for any product development activity to happen. At least there are about 5 to 8 simulation engineers working on all these components to study and check the behavior of a system. Imagine if the Tata Motors is releasing 10 new vehicles, at least they have about a simulation team of maybe 50 to 80 or 100 engineers. I mean, I'm just telling only the powertrain simulation engineers, and that's every company requires engineers, and all the skill sets are required for this is majorly understanding of a system, equations, physics, and things like that. That is the most fundamental thing. And next is the software, which is like a model-based design softwares. And the third thing is, okay, what projects you have done, because projects give you a experience, which is something as an tag of experienced guys will have, right? What they have done, they're a fresher. Like if you compare a 3 years experienced engineer and a fresher, so a 3 years experienced engineer has worked on projects. Exactly, right? What else is difference you would have done? Basically, I've worked on projects, which is a real time. It means when you're working on a project, you do 100 mistakes, and you have 100 plus challenges. Possibly, you have seen those challenges, and possibly you have made multiple mistakes and corrected them, and that's why he's experienced, right? So the same way goes for you too. So if you want to be a simulation engineer or some competitively in the simulation industry, you basically should have a very good, strong foundation skills of physics and good mathematics skills, and then you should have exposure to a tool, and then you should also have worked on various projects on activities. So how do I say I will do a project? you could definitely get something like Decibels, which has been engaged or involved in teaching in a project based approach, taking a real time test cases, taking a real time studies, making you to build some simulation models and study the system exactly. And that's what is something which brings out to activity where you would be able to build it. If not us, there are people who could you could also learn it on your own, and you could be a part of even Formula student teams where they also build the powertrain simulations and stuff like that, and where you will be able to get a very deeper understanding of the simulation systems itself. Like if you see all these things, like I can take another 3 hour session just to talk about how much influences are there, because we have about extensive 2 months, 3 months courses, or even 1 month courses. We just talk about powertrain simulations into a place. So that's pretty much from my side as technically, which I can deliver. I would like to have some questions from you guys to know that what would be the understanding you may have. Okay, what softwares will be used in simulations? Sanket, majorly we use tools like MATLAB, Scilab, Ricardo, Ignite. Then there is a AVL some softwares. There is a GT Suite. So what happens, right? Like, but if you say the market size, hugely MATLAB is used, and but there's also tools like Scilab and other softwares are used. So the software is one part. I mean the requirement in the industry, but definitely the equations and physics and system understanding is very important than the software itself, because you can learn the software very easily. So Decibels itself in the EV manufacturing sector, yeah. So we don't manufacture EV. So we do something as a consulting. So if there is a company who want to develop a EV powertrain, they come to us and we completely provide end-to-end solution in sizing the components and testing the components and validating them. So like for example, if you take a Bosch, right, they won't manufacture a car. Then, but if you see, they supply most of the components to a car. But we don't supply the components. We do an engineering activity where we find a vendor and they will supply the components to them. So basically, we do the engineering activity for startups or OEs in India and also in other countries. So great. And there is a one question: what exactly meaning if acceleration? Uh, I hope you meant as acceleration, not exhilaration. Correct me if I'm wrong, Kunal. Okay, so quite interesting. I'm looking for some questions. The questions you have, it is more better. I'm assuming there are over 94 students participating in here, so it's really appreciated if you guys could ask questions. I could answer to you.
So guys, there are only 10 minutes left. If you want to ask any question, so the platform is open. You can ask.
Yeah.
Students, if you have any question, you can ask. There are only 10 minutes left because as per the new rules, there are only 100 participants allowed and 60 minutes of free meeting.
Yeah.
So if you have any question, you can go for it.
So let me go back because I can't see my screen without I'm sharing. Yeah. So basically, you will provide the knowledge needed to do the simulation. So you will guys offer us job. Okay, yeah, we have a team of like 25 engineers currently. So we don't hire like parallelly from universities or colleges. So we have a an intensive process of hiring, which most of our student employees were part of Decibels already as a students, and then they graduated, they interned at Decibels, and then they become a core part of Decibels. So yeah, so that's what we if you ask me that if I were to get a job at Decibels, there's a process in place. So yeah, we don't expect good grades, but we expect a very good capability skills. That's what we would expect.
Good evening, sir. This is Swapnil here. I would like to ask one question.
Yeah, yeah. Please, Swapnil.
Yeah. Uh, for my students, I would like to ask one question is like, now when we go into industries after completing our BE, the most important point which is talked about is employability. That means the industry expect a lot from students, but the students are not skilled up with respect to what is expected. So
Right.
if I want to enter into this industry of electrical vehicles, which is going to be a future in coming 5 to 10 years in India,
Yeah.
so from where do I start? What should be my basics, and from where should I start? And
Yeah.
then what should be my progression?
Right.
That means I should start from where and how I should proceed if I want to get into this industry after completing my BE.
Right. 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 Great. So fantastic question. I mean, don't take it wrong. I'll just add one point there. Actually, industry is really not expecting too much from students. With my honest experience, because I was at Chrysler. We've been trying to hire, but I think yeah, it's a requirement what every as an expectation as an engineer. So, and coming to a part of employability and how somebody can start. So because when I put across requirements, because we used to hire students from outside, go to college and ask them to put up a requirement and then hire. But honestly, like if there are 100 students applying for a job, I hardly see there are 10% of the resumes matched to our requirement. I mean, this is the same case when I was at Mercedes too. We wanted to hire like 10 engineers for some requirements. We put up a requirement, and there are more than 300 plus resumes, and we have to struggle just to select 10 resumes for the first round of interview. I mean, that is a very tough situation which is there. Everybody have a graduate degree, but very few people have a required skill set. So this is where it comes into a picture like why people doesn't have a skill set. I think people doesn't get an exposure in the very early stage of their education that what they have to do into a place. And how do we address it possibly? Like, I have done one webinar which is available in our Instagram page. If you visit Decibels Lab underscore edu, Decibels Lab underscore lab underscore edu. So there is a Instagram page. I've done a 1 hour live session on that. It's basically there are very decent expectations what industry expects, very good and solid fundamentals of subjects, and that is a very mandatory thing because if you ask something strength of materials, okay, I may not remember, but it is a requirement. At least I should know equations. Equations if I ask the thermodynamics, that is one thing which is always required. And the second thing is nowadays the competition has become very increased, so that means we have to sort of focus towards a specific area, and if I'm good in something it's always better for me. So I urge students to focus yourself into a specific industry segment, maybe automotive, maybe aerospace. Like if you, whatever the passion you have, you don't have to follow somebody's, you can follow your own passion. If you're not interested in anything, leave engineering and do something else for sure, at least for a good own sake, so because after graduating you don't have to spend your 3 years 4 years figuring out what else I'll do, so, but when you're in engineering, spend your time. I know I was an engineer too, and I graduated in 2012. How much free time I will have during my college days, right? But focus yourself to very specific areas. Have a good competency skills in few specialization domains. That's another thing. And a third important thing is do more internships, and that gives you industry exposure. And do good projects during your academics. Maybe if it is a mini project, maybe if it is your pre final year project, if it is a final year project, and have it legitimate. Don't just do it for numbers sake of marks or something like that. Do it for a engineering sake. Where you could just put your time and efforts in to learn something honestly into a place. Do some publications, which I mean is like with all these things you're putting your time. That's all you're trying to do. There is an equation of success, right? If you are able to spend like 10,000 hours, basically you will be the one of the biggest experts in that area. I mean, qualitative 10,000 hours. So it means I know you don't have 10,000 hours to spend as in during the engineering days, but at least I'm very damn sure you have like 1,000 hours to spend. Additionally, if you spend like 2 hours in a day on a specific subject or a topic, by the time you graduate, you will be one of the best experts in that area. I think that's pretty much. I have done this explanation in a very detailed way in my Instagram live video, which was there in for 1 hour. You can just visit. I'm not sure if I can just bring that here, but I'm just telling you it is available there. You could definitely go and check it out too. Yeah, I think that's what something I could tell that maybe students can take it.
Yeah. This is what I always explain to my students. But the thing is, whenever an industry person comes and if he explains, I think so that is a better way, because
But
I
they will.
think, yeah, what you was trying to say is that right from second year, when they come into their core field, they should
Yeah,
start looking for internship. They should start looking for which field they need to pursue their career in. Right? This is what you're trying
exactly,
to say.
exactly. I
Yeah.
mean,
And right now, what I like to add one more thing is that the University of Mumbai has now compulsory introduced mini projects for every semester and internships for every semester. So I
mhm.
think so if students take that thing seriously, they can really it can really add up to their career development, right?
Yeah, absolutely. I mean, that's the need, because
Yeah.
I'm a very chilled out, likely person. I'll tell you, it's the karma is a dash dash. If you don't listen today, you will listen one of the other day. After
Yeah,
your
yeah,
graduation.
exactly. And now they have the time, they can do it.
Exactly. So that's the
Yeah.
motivation for you. After your graduation, don't spend your ninth semester, 10th semester, which I mean is your fifth year of engineering after graduation. Utilize as best as possible. I know you all want to enjoy, even I wanted to enjoy in my engineering. But yeah, if you could settle down something which is very solid on the one side, because you've chosen your career as an engineering with studies. So I think that's pretty much from my side. It is not only EV. So this video is here. If you guys, this is our page. The video is here. This is about a 1 hour. I can't just play because I'm not logged in. So you could watch that. I think I've done it extensively. It helps you out, and definitely it's pointed out by faculty. These are the students who have completed Decibels courses. They don't have super, like special skill sets, but they have right skill sets, and like big companies like this were able to get placed. It all matters is what skill sets you have, what competitive knowledge you have that will help you to pick up your career into a place. So that's pretty much from my side. And there is Saurabh, who has been coordinating all these activities, and he's also the campus ambassador with Decibels. So you could definitely get in touch with him, and he could help you out if you would like to learn something from Decibels as a overall. Great. And we have, I think, last two questions before the meeting ends on its own. I'll just take these questions. So, is any resources to have a real test cases data industry experts have previously worked on, just to practice such test cases to have understanding on the workflow? How closely this is related to a machine learning? Okay, yeah, definitely there is a lot of publications and research papers available. That is all done by good, capable people, and that is also available in that proven data format. You could refer a lot of journals, authentic journals. Information is available. If you have all that, skill sets to self learn. If it's challenging for you, yeah, we do teach at Decibels on all these courses where we use real time test data, where our models are like up to 92 to 98% accuracy, which is more than enough for industry requirements too. So how machine learning is required? I think it's a very wide topic. How do I answer that? It depends, which area of industry it is in. If you talk about like in areas of EV, in battery management system, we use machine learning. In motor control algorithms, we are trying to use machine learning. In terms of health predictions of the vehicle, in terms of health predictions of the battery, we're trying to use machine learning. So we are using machine learning in many ways. Maybe that would be another big topic. I could take it up in another discussions. Practical data is standard data available for different parts. Data can always be collected. That if that is so easy, it would have been very good. But the data is a gold. At an industry, nobody would give you that data for free. I would tell you on straight. Even for us also at Decibels, like we won't just give the data for somebody, because you would have put a lot of man hours, right? It means you would have put time, and time costed money, and we would have all paid our employees and facilitated to create this data. So it is very tough to get it, but yeah, you have resources. If you pay for it, you could surely get it. But yeah, if you don't need to worry as a student to do all these things, honestly to tell you, because it's what required the industry. But for you, you could learn what is available in the open source and pick up your skills, get it competitive. Maybe the last line, it's 3:27. I don't know where the meeting may end up. So you have a lot of time. Focus yourself onto very specific area. I'm not telling you should do only EV or something else. What I meant in overall is, if you could learn something, if you're competitive in something, it means you can be competitive in something else too, right? Because you never know which industry you'll get hired for. But when I hire somebody, what I look is, okay, this guy has done something competitively in this area. Maybe he has done projects, he has published papers, he has done research in that area. It means he is capable. It means he is competitive to do things, and then it means he is competitive to do something else, which I'm going to assign to him also. Correct? That's what I'll majorly look for when I look for a resume. I really never cared about what marks you have, what grades you have. But I'm sure it is very important too. You can't be very negligent on your marks because at least scoring 60 is not a big thing. At least, I would say. So, I mean, apart from it, that's all I would say. Just you can see to that Instagram video. I think it gives you a more better idea in terms of what skill sets you could be prepared with. Great. I think that's pretty much from my side, and appreciate everybody for joining in, and appreciate hosting the whole session into a place. And over to the host
Yeah.
to discuss any questions.
Yes, all students, you can join the EV community on WhatsApp for more details. The link is in chat box. So actually, sir, there are many more students who want to join, but because of the participants limit, they couldn't join. So we will make this
Oh,
seminar available on our
okay.
department YouTube channel so
Okay.
that anyone can see this. Okay.
Right. Right. Right.
So thank you, sir. Thank you. It's my honor and privilege to propose a vote of thanks on behalf of Department of Mechanical Engineering of VIVA Institute of Technology. I thank you, sir, for taking out time from your busy schedule and conducting such a great session. The session
Yes.
has surely enlightened all the participants to the future of automobile industry, that is electrical vehicles. So thank you, sir. Thank you once again for taking out time, and we will look forward to take such more interactive sessions in the near future. So thank you once
Definitely.
again, sir. Yeah.
Thank you very much, everybody, for inviting me and giving me an opportunity to share things what we know. And kudos for your future. And just future lies in your hand. That's it. Put your efforts. Things are going to
Yeah.
happen. With that note, yeah, maybe just take one small picture of everybody who is joined here. I'm not sure if that's something, Saurabh, if you could do it.
Uh,
I'm not sure if that. Okay, anyway, if it is not coming in, it's totally fine.
just a minute.
Yeah. Okay. So yeah, that's pretty much then. And thanks everybody for joining in, and thanks for the opportunity given. And all the best. Take care. Bye bye.
Okay. Yes, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.